this is a simple life form. It is a cell. So it is a simple, what is considered a simple life form. A cell is a factory, an absolute factory. You have tubules, for example, that move materials from point A to point B. When you go into a factory, what happens? You look overhead and materials are moving. Here you have tubules that form to allow you to transport things, and then the tubules break up and form somewhere else. Why don't they just leave the tubules? Because the cell would become too rigid and you'd run out of the tube material. So it deconstructs and reconstructs. There are entities in here and organelles which their function is absolutely extraordinary. This isn't a simple life form, just one cell. Abiogenesis is the prebiotic process wherein life, such as a cell, arises from non-living, simple organic compounds. On our planet, this is what it is. In our universe, this is what it is, as far as we can tell. We're the only ones here so far. But certainly on our planet, it's carbohydrates, nucleic acids, lipids, and proteins. Proteins are polymers of amino acids. Carbohydrates are sugars. So it's just these four classes of compounds, carbohydrates, nucleic acids, lipids, and proteins, make up the substance of life as we know it. All of this is needed long before evolution can ever begin. This predates evolution.
The amino acids are the building blocks of the proteins, right? At each one of these sites, how many possible amino acids could be part of a growing protein? Do you know this from the biology? That there are 20 possible protein-forming amino acids, okay? So you've got a 1 in 20 chance at each site. So to get at two sites, how many possible combinations do you have? 20 times 20 again, so 400. If then you go to 3 sites, how many possible combinations? 20 times 20, the 400 times 20 again, 8,000, very good and quick, okay? Now 8,000 times 20 again, 160,000, and we're only to 4, okay? So there's a vast number of possibilities. You've got a 1 in 20 times 1 in 20 times 1 in 20 times 1 in 20, going out however many sites you have for amino acids. So in a chain of amino acids that's just 10 sites long, you're already to 20 to the 10 possible combinations. That's 10 trillion possibilities. So we'll do that same calculation. We've got 150 sites with 20 possibilities at each site, 20 to the what power? 150th power. Convert that to base 10, that's 10 to the 195th power. We can't even begin to grasp how many combinations that is. He wanted to find out how common or how rare are the functional sequences of amino acids among the big space of all the possible amino acids there are. And he chose to work on a protein of about 150 amino acids to start to get an answer to this question. How many combinations of amino acids are there? You kind of get the idea? He's trying to get that marbles to marbles ratio. You know, this is like the red marbles we want and the blue ones that we don't, okay? And he came up with a really amazing number. If you want to build a protein, we know from chemistry that you have to attach the amino acids together with what's called a peptide bond. In nature, peptide bonds occur with about a 1 in 2 frequency. Half the bonds that form between amino acids are peptide bonds, half aren't. But if you get any bonds forming that aren't peptide bonds, you can't form a protein. So to form a protein, 150 amino acids long, you've got a 1 in 2 chance at each site of getting the correct type of linkage. So you got 1 in 2 times 1 in 2 times 1 in 2 times 1 in 2 to the what power? Close to 150. Since we got linkages, we have 149, but call it 150, okay? So in other words, we got another huge exponential problem to overcome. Wow. Now, can anyone get their mind around a number that big? There's only 10 to the 80th elementary particles in the entire universe. There's only 10 to the 16th seconds since the Big Bang. There's only 10 to the 139th total events since the beginning of the universe. Now you're starting to get the understanding of why people are very skeptical that the chance hypothesis is going to do the job. No serious scientist thinks this is the way it happened. It's always going to be more probable that it didn't happen by chance than it did. And with that kind of reasoning, you realize it's time to move on and look at some other options.